Hello and welcome back. Just a little follow-up. As you can see, I have the carriage working. The nylon cord I had to go with is the kite string. This little fella down here is binding every now and then, and you'll hear a click, but really I'll be redesigning him shortly to match this side a little better. I had to make the larger hole go straight through because the nylon cord windings were actually falling off and going down to the smaller axle. It's not much of a problem. I just reprinted the part out, which is a great thing about 3D printers. This little fellow in bipolar motor takes 2048 steps in full step mode to do a full rotation. So I have the Mega just pulsing out 2048 steps, and then slight pause, flipping the direction pin from high to low, and then going in the other direction. So we have this nice back and forth motion. I did a test earlier just by putting a weighted object next to it to see once it pushed the object, it would if it would return to it. I'll just try with this here. Push it, and then it should just come up and kiss up to that there for a long time. It's a geared motor, so it's very strong. I put some heavy things on it, like that's one of those hole cutting drill bits. It weighs a pretty decent amount, so yeah, if you've used one of those, you know how much they weigh. It can hold quite a bit more than that. In fact, I put one of my DC engraving motors on it earlier, but when it's sitting like this, it doesn't sit in a way that I could rest something on it right now. Mainly, this is slow, but because of the gears inside, it's incredibly strong. It's not even getting warm, and it's actually been running now. I think it's been running for 20 minutes as I'd started doing some tests before the video. And the Arduino Mega is a bit of an overkill for this, but this is one of my quick go-to boards for when I'm working on ideas. And then I just work things down to a smaller number of pins, so it will eventually run on this. I'll get it on one of these nanos in due time. Something else I'm going to take a quick minute to mention. That easydriver board is not the one you saw in the previous video. This is. I killed it. I killed it because I made a stupid mistake. And yeah, so stupid mistake. How to kill your easydriver. More specifically, the Allegro chip. I could desolder that chip, put a new one on it, and that board would probably be alive again. It's just not really worth the hassle considering how cheap these modules are. I snapped off the heatsink, put some new thermal tape on it, and yeah, this is, I think it's my body temperature. Just gonna take that off there, put that away. So, what happened is, you see these wires that I have going from the stepper motors cable to the board. They were brand new, and when they come new, there's sometimes a little bit of oil or a plastic on them. And they'll connect, but sometimes the connection isn't that great. It can be intermittent because the oil interferes with the connection. And easydriver boards should never be disconnected from a coil when they're powered. If they're powered up, don't disconnect the load. So if you've got the motor side of the easydriver power up, don't disconnect your load. It will most likely kill the driver chip. This IC will die. Those were new. I've since cleaned the tips, the oil off them. But what had happened is, when I was working on this, the USB cable that I had plugged in bumped one of the wires, and that, I guess, interrupted the connection just long enough to fry the Allegro, this IC. Wasn't sure at first, but I did. I went to the easydriver website, and on the easydriver website is the steps for ohming out the pins, so you can test to see the 4 motor control pins. Just looking to see where my handy dandy little pointer went. Just grab a new one. A box of them. See if I can lift this up here to where we'll see it. So on these, see this here? There are the 4 motor pins, and when you take the resistance between them and the ground, it should be over 1 megohm. And when you take the resistance between them and the motor plus, they should be 1 megohm each, and between each other they should be 1 megohm. Problem is, now that it's dead, they are nowhere near 1 megohm to ground. They're fine in all other aspects, but between those, each one of those to ground, it's I think something like 100 ohms, which means fried. You can also check your voltages and whatnot, and definitely the output is shot on this. It's just not worth me getting another one of these chips and soldering it on at this point. I probably won't check it out because maybe one day I'll want to do some practice soldering at that size, but really it's not worth it at this time for me to mess around with that. Anyhow, yeah, so be careful with your easydrivers. Don't make my mistake. Don't disconnect your load with it running. Other drivers like the Adafruit motor driver, which I have one but just not handy at the moment. It's a shield for the Arduino Uno. You can disconnect the load on that. However they've got it done, I'm not sure, but you can actually disconnect the load, whether it's a unipolar or a bipolar. It's a really neat board for learning stepper motors and motors in general. It's essentially a dual H bridge with some control software on it, or a control chip. But these ones not so much. You want to make sure your connection is good. Don't disconnect it. Try not to bump it while you're testing. And wherever possible, make sure your connections are solid. And try not to use these jumpers for very long. For the purposes of this, where it's not moving, it's just fine. As we can see here, the whole time we've been talking, yep, it's hitting the right spot. You can just hear a bit of squeak coming from that right now. Yep. Nope, this side's deciding to squeak now. Just a little bit of friction down there. It wasn't really built for much more than a light test, light duty things, but that's as fast as this motor goes. I think the limitation is just frequency. Again, that's a full, the distance you're seeing this carriage move, because that's a 1 centimeter pinion, is based on 1 RPM of this. That's the travel you get. Perfectly good for a laser when I have this over top of the shell of a flatbed scanner or a different axis. You could easily use a laser with that. It's not going to be terribly fast, but I wasn't going for that. I could always use one of my other stepper motors, something in the larger NEMA family. But anyhow, that's the update. Probably a little bit longer than I intended, but didn't really want to hide the failure. Totally avoidable. Not the module's fault. That's my fault. And just thought I'd put it in there in case somebody else was using it and wasn't aware that disconnecting the load is very, very bad on these. Anyhow, if you have any comments, be sure to leave them below. And if you like, and subscribe. And as always, thanks for watching.